This video lecture is meant to introduce the information in Honors Chemistry Unit 5, Section 4 on quantum numbers. And really what we're trying to do in this section is to describe, the quantum numbers are meant to describe the location of an individual electron. And it's sort of like a code, a 4-digit code. And the numbers start from the most general location where that electron is to the most specific location of where that electron is. And so what we have here is we have the four numbers start with principal, went too far. The primary quantum number corresponds to the principal energy level, PEL, abbreviation for principal energy level. Sometimes you see letters that are associated with each of the four numbers. Primary quantum number is represented by the number N. This is really trivial. I'm not really interested in you knowing too much about this other than that it exists. The primary quantum number can be anywhere from 1 to 7 because there are 7 principal energy levels, which also corresponds to the number of periods or rows on the periodic table. The second quantum number, sometimes referred to as number L, again, trivial information, just recognizing that they have these symbols. But the second quantum number corresponds to the sublevel S, P, D, or F. And if the electron is in the S sublevel, it has the code number 0. If the electron is in the P sublevel, it has a code number of 1. If the electron is in the D sublevel, it has a code number of 2. And if the electron is in an F sublevel, it has a code number of 3. The third quantum number, represented by the symbol M, corresponds to which orbital in the sublevel the electron can be found. Now, if we are looking at this diagram right here at the bottom of your slide, at the bottom of your screen, you remember that S has 1 orbital, P has 3 orbitals, D has 5, and F has 7 orbitals. And so depending on which orbital the electron is in, there's a code number. And if you recognize the code number is centered around the middle box, and then it's like a number line out to the right and to the left. So any electron that is found in the S sublevel, there's only one box, so it's going to just have that code number of 0 right there. Okay, If the electron is found in the P sublevel, depending on if it's in the center, it's going to have a code of 0. Off to the right, code of +1, and off to the left is a -1. D, the middle orbital, is centered around code number 0, 1, 2, and then to the left is -1, -2. F, the middle orbital, is 0, 1, 2, 3, off to the right, -1, -2, -3. So depending on which one of those orbitals the electron is in, it'll correspond to one of those numbers. And that's the third of the 4 quantum numbers. The fourth quantum number, represented by the symbol S, don't worry about that, corresponds to the electron spin. There's only 2 possibilities for the fourth quantum number. Either it's a +1/2 or a -1/2. If the electron has an up spin, we represent it as a +1/2. A down spin would be a -1/2. So again, we're looking at 4 quantum numbers, kind of like a code to help us describe where electrons can be found. What you're looking at here is an orbital diagram for the element of bromine. Your first task is to circle the electron that can be found at 3, 1, +1, -1/2. Right? So if we're looking at this 4-digit code, the first number, it means that the electron is in the 3rd principal energy level. So that means anything in the 3s, the 3p, or the 3d. The second digit of 1 is referring to whether it is in the S, the P, the D, or the F sublevel. Remember, the S sublevel is 0, P is 1, D is 2, and F is 3. So now we are looking to find this electron in the 3p, because that's the second number of 1 corresponds to the P sublevel. The third digit corresponds to which orbital the electron can be found in. And since this is P with 3 orbitals, this middle orbital is 0, the orbital to the right is 1, and the one to the left is -1. So now we're looking at either one of those 2 electrons in the right-hand box. The final digit is referring to the downspin, so the -1/2 means we are specifically looking at that electron right there. Let's try another one. Triangle. Put a triangle around the electron at 3, 2, -2, +1/2. Okay, I'm going to erase this so we can do this process all over again. All right, so 3, 2, -2, +1/2. We're still looking at some electron that is in the third energy level, one of those three possibilities. Right? The second quantum number of 2, remember S, P, D, F, I shouldn't have erased those, 0, 1, 2, 3. So the fact that this is 2 means it's in the D sublevel. So now we are looking at the electron has to be here. The third quantum number of -2 is referring to which orbital the electron can be found. Remember, it's 0, 1, 2 off to the right, -1, -2 off to the left. So we are looking at somewhere in that first orbital the electron can be found. And with a +1/2, we are very specifically looking at the up arrow right there. So quantum numbers is just a way to symbolize or give a code for where the electron, a specific electron, can be found. So the next question is, where would you find an electron with these numbers, 2, 1, -1, -1/2? So 2, the first number of 2 is referring to, it's got to be somewhere in here. The second number of 1, SPDF, remember SPDF, 0, 1, 2, 3. So we are now looking at specifically in the P sublevel. -1 puts it here. And -1/2 means we are looking at that down arrow. And I suppose I should have written that a little bit to the right in that box, but it's the down arrow that those numbers are referring to. How about this one? 1, 0, 0 +1/2. The fact that it's the first principal energy level means that that electron has to be in that spot. 0 means it has to be in the S sublevel. And if you have an S sublevel of 0, then the third digit also has to be a 0 because there is only one box. And the fact that it's a +1/2 means that we would have an up arrow in that box. Okay, so that's how you work those